Next, we will show the variance of best estimate of treatment contrast. Variance of best estimate treatment contrast A dash alpha in BIBD is K by lambda V A transpose A sigma square. Variance of best estimate of A dash alpha in BIBD is K by lambda V A dash A sigma square. So we have to prove that, show that. Okay. Variance of best estimate of A dash alpha cap in BIBD is K by lambda V A dash A sigma square. So we know that what is the best estimate of treatment contrast A dash alpha. The best estimate of treatment contrast A dash alpha equal to alpha is A dash alpha cap, right? Which is equal to A dash here alpha cap equal to K by lambda V into Q. Then what is the variance of best estimate? The variance of best estimate is A dash mu sigma square, right? Where mu is any solution of C mu equal to A, right? Which implies that mu cap equal to K divided by lambda V A. Therefore, the variance of best estimate of treatment contrast equal to A dash mu sigma square equal to A dash, here mu value is K by lambda V A, and here sigma square. This is the variance of best estimate of treatment contrast A dash alpha in BIBD. Then we'll find out what is the efficiency factor of BIBD. We'll find out what is the efficiency factor of BIBD. How to find out the efficiency factor of a design? For a design, we can find efficiency factor as a ratio, right? Equal to V bar R divided by V bar, where V bar is the average variance of all the estimated elementary treatment contrast for the design under consideration, and VR bar is that for RBD. So here, what is VR bar? Is average variance of all the best estimate of V minus 1 divided by 2 elementary treatment contrast, right? That is VR bar equal to 2 sigma square divided by R. This is for RBD, right? If in RBD design is not equally replicated, then we can take VR bar equal to 2 sigma square divided by R bar, where R bar equal to R1, R2, so on, Rn divided by n. This is the average variance of all the best estimate of V minus 1 divided by 2 elementary treatment contrast in randomized block design. So here this V bar is average variance of elementary treatment contrast in BIBD, right? Here we want to know what is the efficiency factor of BIBD. That is, here average, here what is variance of elementary treatment contrast in BIBD is equal to 2K divided by lambda V sigma square. What is elementary treatment? Elementary treatment is if C has only two non-zero values, right? 1 and -1. Then variance of elementary treatment contrast in BIBD equal to 2V divided by lambda V sigma square. Then you'll find out the efficiency factor of BIBD. That is E equal to V bar R divided by V bar is equal to 2 sigma square. Here V bar R is the average variance of all the best estimate of elementary treatment contrast in RBD, right? Which is equal to 2 sigma square divided by R divided by here average variance of elementary treatment contrast in BIBD, that is V bar equal to 2K divided by lambda V into sigma square, right? Which is equal to here sigma square cancel, 2 could cancel, then that value equal to lambda V divided by K R, right? Then here we want to know whether these E equal to this value is less than 1 or greater than 1. Then we can compare, right, which one is more efficient. So for that we can use the second relationship between the parameters, that is lambda V minus 1 equal to R K minus 1. So here lambda V minus lambda equal to R K minus 1. So here take lambda V equal to here RK minus R then plus lambda, this lambda. Then divide RK by the whole term. This lambda V divided by RK equal to 1 minus R RK plus lambda divided by RK. It's equal to 1 minus R RK. You can write this form as R minus lambda divided by RK, right? Which is equal to, here we know that R is greater than lambda. So this value is is a is integer, right? Then this value got, then these value become less than 1, right? Here 1 minus some positive number, which implies that it is less than 1, right? This value is less than 1. So lambda V divided by RK is less than 1, which implies E is less than 1, right? Here these values are E, right? E equal to lambda V divided by RK. Then E is less than 1. Therefore E is less than 1. Then this value is greater or less. The variance of RBD is less, right? So BIBD is more efficient. You can say that BIBD, here variance of R is less, here variance of R is greater, right? So we get efficiency is less than 1. Then you can say that RBD is more efficient, that is BIBD is less efficient than RBD. Then you can say that BIBD is less efficient than RBD, right? The next